Okay. Hello, everyone. My name is James Bokheim. I'm with DefendEye out of Poland. About 3 years ago, as I was living in New York, there was a fire next to the building where I live, and about 6 fire trucks came very, very fast for that fire, and nobody was touching the building until somebody took out a drone, and it was flying in the air. So it took that person about 3 minutes to set up the drone, unpack it, and put it up in the air, while firefighters were there just waiting. Can we go in? Can we go in? And then after the firefighters came in and they were in the building, there were 3 guys looking at the monitors. There was 1 guy piloting the drone and 2 guys looking and directing the traffic of firefighters in the drone. And I thought to myself, well, that's wrong. There's 2 fundamental problems, and that's what we're here to solve. The problem today in drone market, in the whole drones, whether they're military or commercial, is that it takes at least the fastest you can deploy a drone from a packed position is 3 minutes. Whether it's an emergency or a search and rescue, 3 minutes is an eternity. The second problem is that you need to train pilots. You cannot just fly a drone and bring it back. You need to train people. Again, you can have a drone and fly autonomously, but the taking off and the landing is always done through a pilot. And so what we did is we built a drone, as you can see here. This is our drone, and this is the launch tube. Sorry. And the launch tube, the combination of this allows us to deploy instantly from any condition. It could be stored for a year, and you can just immediately launch it in the air within under 10 seconds. The second thing is that it doesn't need any pilot to fly. It just goes up in the air, and it's trained to search for specific objects and just fly to those objects and then come back to the original point. We have 2 versions of the launch tube that you see here. We have the portable one, and we have the stationary version. The launch tube itself, it has 3 ways of sending the data or giving the data to the user. It has a built-in 4G modem, so it relays the data directly to the cloud. It also has Ethernet and local Wi-Fi. And so what we've done is inside the drone, there's a camera, as you can all see, and there's an AI chip that we've been training. So each drone has, in its disposable, it has an AI chip that we've been training. The first thing that we've trained it to do was to identify humans. So it can go up in the air and it can see humans, as you can see here. Each one of those triangles are a human, and it does a better job of detecting humans than us. So if I were to show you guys a screen video from above, we're not really good at identifying humans from above, but this does a really good job from very high altitudes. And we can train it to detect not only humans, but buildings or specific things that I can explain in one of the use cases later. So yeah, so then we build our cloud, and as I mentioned, the relay, the launch tube relays the data to the cloud, so any user can be remotely, whether in a control room, it could be in Australia, and you're deploying in other places. What our cloud does, it also records the data, it processes the data, it streams the data live, but it can also detect anomalies. For example, something changed. So in a construction site you're building, you can launch the drone once a day and it can detect what has changed, or if a crane has moved from original position. So we have multiple verticals, multiple use cases, not only first aid or first responders, and I will show you. So for example, firefighters, you can install the launch tube directly on the truck, and as it arrives on scene, before even turn the engine off, the drone can be immediately on the air. Maritime, so today there's a big problem when you have man overboard. You have a ferry transporting people, somebody's missing, you go to the captain, hey, my friend, I don't see this guy. Immediately he stops and he starts to go back. There is no solution today solving man overboard with a drone, because it takes at least 3 minutes and you need a pilot. And ferries don't have that capabilities. But here you can have the launch tubes installed directly, or if it's not commercial but private, somebody fell, you can immediately launch it, and it'll identify where that person is, and the pilot or the captain can steer the boat towards that area. Perimeter protection, so we can you can install the launch tubes on the border. on fences, but not only water, it can protect different installations, and it could be triggered, the drone, the launch can be triggered by a specific event. For example, if there's motion on sensors, somebody can launch, they could be really far away, and they can then see, okay, that's an animal, or it's really people, or somebody's trying to penetrate the installation. We're speaking with home insurances right now, where if you have damage on your ceiling, on your roof has damage, and you call the insurance, they send an appraiser, take pictures of your house, they even have to fly a drone. The problem is that the appraiser has to come to your house to take the pictures, and he has to have a drone, he has to know how to fly the drone. Why you cannot just ship the drone in a box to the homeowner? He just launches it, it flies above, comes down, he returns the drone, they have the video, and he gets his money. So there's, as I explained, there's multiple use cases, both in the commercial, but also in the search and rescue, that we solve that they are not solvable today. A little bit about us. So I'm the founder. This is my 5th company that I've done. I've done already 5 startups. All of them exited. The last exit was very, very large. All my coworkers became multimillionaires. With me, there's Ben, who is the assistant professor for aeronautics and drone design at the University of Oklahoma. If you are studying law, you go to Harvard. If you want to learn how to do drones, you go to the Oklahoma University. Yeah, so that is a little bit about us. Our team is made out of, we're 9 guys. I guess most of us are software AI developers. And if you have any questions, we're also here and glad to speak with you. In terms of we're right now looking for a seed. I've been funding, so we're bootstrapped. I've been funding the company, but now we're looking to expand. We started a small production, so we've already built 25 of these, all in Poland, and we're looking to start both commercially manufacturing and start marketing this. Thank you. Questions?
So just on the last topic, how much are you guys raising?
We're raising $1 million.
All right. In terms of maybe the problem as well, what makes it tough today? Maybe you can expand on that a little bit. Why does it take 3 minutes for a drone to sort of start operating today?
So, because most drones, they can pack military, or if you have a commando unit, or if you have firefighters, they all come in a briefcase or in some packaging. And so the idea is that you have to take it out, put the battery, connect to it, pair your phone or pair your tablet, and then you have to wait for GPS. And then once you're ready, you have to find a site where you can take off and land. Because this is launched from a launch tube, just look above and it's done. So this solves this problem.
In terms of the computer vision side of things, are you guys doing like in terms of the algorithm? Is it proprietary, your own algorithm? How does it work?
Yes.
Do you think there's a proprietary portion in that as well, or is it is it getting more and more commoditized?
So in terms of proprietary information, we do have 3 patents that we're waiting to be assigned to us. 3 different patents in 3 different areas. So there's a lot of IP. Almost all drone manufacturers today, they do not design their drone. They either copy each other or they use an existing platform. We had to completely from scratch design this, not only so that it can be launched from a launch tube, but also so that it can be economically manufactured and it could be, if need be, disposable and eco-friendly. In terms of the AI, we are designing our own. We're using an existing algorithm called YOLO. So we're using YOLO, but we are training. We're using our own data sets. We're flying from above and identifying a human. There's not a lot of data sets, specifically in the water, specifically urban scenarios, and then mixing all that. So it's a lot of work. And I would say that even further, trying to minimize that work and make it run on a low power computer vision solution is extremely hard. And this is low power. It has to be very low cost. If I had all the money in the world, then I would put an NVIDIA here, but we don't have that. We're not that fortunate that we can put an NVIDIA chip.
Great. Thanks so much. Super interesting. One thing I was curious about is you said it's much easier to operate by an individual, so it doesn't have to be a professional. Is that because it's sort of not fully autonomous, but it's more capable of understanding what it needs to do, where it needs to go, and less dependent on the human inputs on the controller, or what's the difference between how that's operated versus your average drone?
So Actually, our marketing, what we're telling when we're speaking with customers, we're telling that my grandmother can operate it. So there's two ways that this operates. It is fully autonomous. So it can be operated by just pressing this button and it just goes up in the air, but it can be also operated remotely or by a sensor. For example, we're speaking with gasoline stations. We're trying to do a trial where this will be installed on top of the gas station, and there's a sensor that measures heat, and if that sensor understands that there's over 80 degrees Celsius, it just launches up in the air, means that there's fire at the gas station, and this transmits with a relays the information, the video directly to the firehouse or the firefighter's house, and so as they're en route, they understand how big the scene is and how many trucks to deploy. So it's completely autonomous, and there's no need for anybody to really intervene here.
Thank you. Awesome. Looks really, really cool. I had a quick question about customer segmentation, right? You mentioned a whole load of different use cases here, quite a broad set of different use cases. Where are you going to start and why? Where are you going to start? Like,
so as we have so many verticals, so many unique verticals that we can go. Military, police, firefighters, insurance. Our aim is really to find the 2 or 3 verticals, the lowest hanging fruit, and just go there surgically and go there. So we're not going to be like all over the place and oh yeah, it's really going to be the lowest hanging fruit, shorter sales cycle. With military, sales cycle could be 2-3 years. So we're looking at where we can go and really start getting revenue as fast as we can.
cool.
Really interesting. Thank you very much. I have a bit of a different question more on the product side. Yes, if I understand correctly, would you then do your own models directly on the drone itself, right?
Yes. So the models run directly inside the drone.
Yeah. And how does it's because I think when we look at a lot of the companies that also deploying the models on the device, there are some cases where, because obviously there's also not enough training data, I think, available, so you have to build the data set yourself. How do you see the performance state of the models today in terms of what they can do, and I guess where it will be, in 5 years' time?
So right now what we're trying to do, as I mentioned, we're trying to identify the use cases and then train the models for those use cases. As an example, which is a great question, we cannot train it to fight humans on the forest and on the ocean at the same time. It's completely different training data sets, and it doesn't fit in our chip. Our chip has only 256 megabytes of memory. So what we're doing is really trying to separate the models. Okay, this model is a marine model alone. This model will be used in a forest or different areas. So we're trying to separate that and creating, as I mentioned, the verticals, and then creating firefighters. It will be just to identify smoke. So it'll go up in the air, it'll identify a building with smoke or fire, and it'll just fly there and just hover above that area. So it is really about narrowing the size of the memory that we have to train, and then just doing it vertically today. We are using today a RISC-V chipset, so very limited on what we can do, but that's okay. I mean, we don't expect that we're going to sell a unit and the firefighter is going to go and take it for different use cases. It's going to be separated. In terms of the future, hopefully we can train it more and then really merge into a complete unit that does more in one unit.
Yeah. Yeah, no, very interesting. I mean, it also makes a lot of sense that you start with very narrow in a data search and then obviously expand as you go deeper into one use case or across other use cases. No, very interesting. Thank you.
Thank you. Thank you very much.